Hi everyone, students. Today we will take up some important questions from thermodynamics for NEET and JEE exam. Okay. So I have selected some of the questions. So get ready with pen and paper. So first, let me show you the questions. You can try it by yourself. 1, 2, 3, 4, and 5. Okay, students, let's try this. 1. What amount of ice will remain when 52 grams of ice at 0 degrees Celsius is added to 100 grams of water at 40 degrees Celsius? It is given that specific heat of water is 1 calories per gram per Kelvin and the latent heat of fusion of ice is 80 calories per gram. Okay, then here so there is ice at 0 degrees Celsius and it is added to 100 gram of water. Okay, so in doing so the ice will be converted to water. Okay, so he asks that how much amount of ice will remain. Okay, will remain as ice. Okay, then so let's start. Okay, this is a phase transition here. Ice changes to water. Okay, this is a solid, this is liquid. Okay, and at 0 degrees Celsius they are at thermal equilibrium, as we learn in physical equilibrium. Okay, at 0 degrees Celsius ice and water are at equilibrium. That is, at this equilibrium point, heat absorbed by ice will be equal to the amount of heat lost by water. Clear? Okay. Then heat absorbed by the ice we can express in terms of, here let me say Q ice and Q water. Q is equal to M into L, where L is the latent heat. Okay, for Q is equal to mc delta T. So let's put the values, where M is the mass, C is the specific heat, delta T is the change in temperature. So mass 100 gram of water, specific heat 1 calories per gram per Kelvin into delta T, 0 to 40, so 40 Kelvin. Then M latent heat is 80 calories gram per gram. Okay, let's first cancel all the unit. Calories, gram inverse, Kelvin inverse, Kelvin. So the only unit left will be gram. Okay, so let's find the mass. M is equal to 100 into 40 divided by 80 gram. M is equal to 50 gram. 50 gram. Okay, so it means that there was at the beginning 52 gram of ice was okay, it was mixed with 100 gram of water. Okay, so in doing so 50 gram of ice has already changed into water. Clear? So the amount of ice left, okay, the amount of ice left will be, so initially there was 52 gram, now 50 gram has already changed due to absorption of heat, so it has already changed into water. Okay, so 52 minus 50 is 2 gram, so the answer is 2. Okay, then students, We'll go to the next one. Question number 2. The heat of neutralization of HCl by NaOH. So let's write HCl plus NaOH will give NaCl plus H2O. So therefore here the heat of neutralization is minus 55.9 kilojoule per mole. If the heat of neutralization of HCN by NaOH, okay, HCN, hydrogen cyanide with NaOH, we will give sodium cyanide NaCN plus H2O. And for this, let me write H1, H2, okay. Del H1, del H2 is minus 12.1 kilojoule mole inverse. Okay. So the heat of neutralization of HCl and NaOH is given, and the heat of neutralization of HCN and NaOH is given. Okay. So the energy of dissociation of HCN means HCN, when it's dissociate, it gives H plus Cn minus. Okay. Cn minus. So we have to find the heat change for this dissociation process. Okay. Okay then, students. So let's find here. So in this equation, I need only Cn. Okay, this is here, and on the right side, I need H plus and Cn minus. Okay, Cn minus is already there. So H plus, it is okay on the left side. So I have to reverse this equation. So let's reverse the first equation. Okay. So let me write here NaCl plus H2O, HCl plus NaOH. Okay. So delta H1 is equal to, when I reverse, this minus sign will change to plus. Okay, plus 55.9 kilojoule mole inverse. Okay, then here after this, let's add this new equation to the second equation. Okay, so let me write here HCN plus NaOH NaCN plus H2O. Okay, let me add these two equations. For this, delta H2 is equal to minus 12.1 kilojoule per mole. Okay, so let me cancel H2O, H2O, NaOH, NaOH. Okay, so let's write HCN plus NaCl. I will write Na plus Cl minus. Then for HCl, I will write H plus Cl minus. For NaCN, I will write Na plus Cn minus. Okay. Let me cancel the terms Cl minus, Na plus, Na plus. So lastly, I get here HCN is equal to, gives H plus and Cn minus. Okay, H plus and Cn minus. Okay, so this is a required equation, so which is obtained by reversing the first equation. I reverse this equation, then I add to the second equation. Okay, so let's find the value here. The last value will be 55.9 plus minus 12.1. okay, 12.1. so the answer will be 98 plus 43.8 kilojoule. Okay, plus 43.8. so the correct answer is 2. Okay. Okay, then let's move on to the third question. If 373 joule per gram heat is exchanged at boiling point of water, then what is the increase in entropy. Okay, so let's solve this. So we have learned that change in entropy is given by Q by T. Okay, Q reversible by T. So here it is the heat exchange is taking place at boiling point, so the temperature will be, boiling point of water is 373 Kelvin, and the heat exchange is 373 joule per gram. Okay, joule per gram. Okay, but in the answer it is given in joule per Kelvin per mole. Okay, so we have to express in terms of moles. So 373 into per mole means I have to multiply with molar mass of water, 18. Let me write here like this: 373 joule per gram into 18 gram mole inverse per mole divided by 373 Kelvin. Okay, so here let's cancel gram inverse. 373 cancel, so 18 joule per Kelvin per mole. Okay, so this is the increase in entropy. So the correct answer is 3. Okay, students, let's move on to the fourth question number 4. Okay, so let's try this. The heat of atomization of pH3 and P2H4 are 228 and 335 kilocalories per mole. Then the bond energy of PP bond will be. Okay, so let's try this here. Heat of atomization of pH3 is 228 and the heat of atomization of P2H4 is 355. Okay, so we have to find the bond energy. Okay, so students, here in pH3 there is 3 pH bond. Okay, so in pH3 there is 3 pH bond, so bond energy of pH bond will be given by 228 divided by 3. Okay, so 3 7 21, 3 6 18. Okay, clear? Okay, so this is the enthalpy of atomization for pH3, and in pH3 there is 3 pH bond, so bond energy of pH bond will be the amount of energy divided by 3. Okay, 76 kilocalories. And for P2H4 there is 1 PP bond and 4 pH bond. Okay, so I can write bond energy of PP bond plus bond energy of how many pH bond? 4. Okay, so let me write here plus 4 times the bond energy of pH bond. Okay, will be equal to 355. Okay, this is for P2H4. Okay, P2H4. So here bond energy of PP bond is equal to 355 minus 4 times the bond energy of pH bond. Okay, so for pH bond the bond energy is 76, so 4 into 76, so 355 minus 4 into 76, I get 6.4 30 304. Okay, so 355 minus 304 is 51 kilocalories. Okay, per mole. So the correct answer is 4. Okay, okay then students, let's move on to the last question here, question number 5. So here students, 2 moles of an ideal diatomic gas is subjected to the following process. Okay, a PT graph is given here, pressure and temperature. So R is given, then we have to select the correct answer. Okay, so first A, work done equal to 0, Q, heat is equal to 44880 calories. The third option is enthalpy change, and the fourth option is internal energy change. Okay, so let's find here. So students, the given graph is PT. Okay, so PVT. Okay, PVT. So let's try to find the volume, okay, from this graph, as pressure and temperature is already given. So let's find the volume and let's choose the correct answer. Okay, so for this point 1, let's find the volume at this point 1 and the volume at this point 2. Okay, let's see how the volume changes. Okay, so at point 1, okay, so let's find the volume at point 1. Since it is an ideal gas, let's apply the ideal gas equation. PV is equal to nRT, then V is equal to nRT by V. P, sorry. So V is equal to N, number of moles is 2, into R is 2, temperature at 0.1, temperature is 47 degrees Celsius. Okay, so let's convert into Kelvin. So after conversion I get 320 divided by the pressure at 0.1 is 4. Okay, so 4 cancel, V is equal to 320. So let's find the volume at this point 2. At 2, PV is equal to nRT, same equation. V is equal to nRT by P. Then V is equal to, number of moles is 2, R is 2, then temperature is 367 plus 273. Let's change into Kelvin. So I get 360, 640. Okay, 640 divided by pressure at point number 2 is 8. Okay, 8. So here after calculation 320. Okay, so let it be V1, let it be V2. Okay, so here V1 is 320, V2 also 320. Okay, so here V1 minus V2 minus V1, that is delta V2 minus V1 is equal to 0. Okay, clear? So work done is equal to P delta V. So work done is equal to 0 since there is no change in volume. Okay, so the correct answer is A. Okay. Okay, students. So these are some of the important questions from thermodynamics. So let's meet again in the next video. Okay, from another chapter. Okay. Okay then, bye students. So don't forget to please like and like my videos. Okay then, bye students.